morning, students. In previous lecture we have discussed about very important topic, instantaneous acceleration, and also we have learned how to integrate a function. Now today our first topic is kinematics equation in uniform motion. Students, you know the uniform motion means when the body has its constant speed or velocity. And you should know also difference between speed and velocity. If I am saying speed, it means it has no direction, and if I am saying velocity means has its fixed direction. So see this. Also yesterday we have discussed about the observation point. Observation point means reference point, you can say. Reference point means reference position. Reference object means from where the observation has been taken from for the moving object. See here, suppose O is the reference point or observation point, and A, B and C, there are three positions on the path of a moving object. Suppose O to A distance is x0, O to B is the distance x, and O to C is the distance x dash. And when observation starts, when object reaches at point A. See here, when object starts observing, then it is at A. Here time is suppose t, and here time suppose t dash. Try to understand this diagram. This is the straight path of the object which is moving towards positive direction of x-axis. When it is at A, it is at x0 distance from the observation point, and this is t equals 0. T equals 0 means when time starts, means the clock starts for observation of the body's motion, then it is at x0. At t time, position x. At t dash time, position x dash. Now see, it's uniform. You can say velocity is direct. Velocity between A and B. Velocity between A and B. If I am writing here velocity between A and B, means it is not instantaneous velocity, it is average velocity between A to B. So suppose velocity is V, uniform motion of the body has its velocity V, and V equals to what? Speed equals to velocity equals to displacement upon time. What is the displacement for A to B? It is AB. AB is the displacement upon time taken. Time taken means time interval. So see here, at A t equals 0, at B time is t, so difference time interval is t minus 0. AB upon t minus 0. So what is AB? AB means x minus x0. AB equals to x minus x0. Why? Because see this, OB is x and OA is x0. X0 you can say. So AB equals to OB minus OA, that is x minus x0 divided by t. Now by cross multiplication, x minus x0 is equal to v into t by cross multiplication, t multiplied by v. So x minus x0 equals to v into t, or x equals to x0 plus vt. This is the kinematics equation in uniform motion in the given path between A and B. Try to understand, this is not a new thing. This is not the new thing. You know the basic formula of speed or velocity. Velocity means displacement upon time. This is same as we have discussed earlier in previous classes. Speed equals to distance upon time. Yeah, distance equals to speed into time. ध्यान समझो, speed equals to distance upon time. So distance equals to speed into time. ये relation यही है, बस difference क्या मिल रहा है देखो. This is the position at time t. This is the position at time t equals to 0, and this is speed into time. Just it has difference of x0. यहाँ पे x0 नहीं है, यहाँ पे x0 है. This x0 is the initial position of the object from reference point. जहाँ से, जैसे इस last diagram में, see this, O is the observation point. यहाँ से उसको observe किया जा रहा है, means इसको reference point माना गया, means from this position distance or displacements are measuring. So when it is at A, so position is x0. So this is the initial displacement or initial distance traveled by the body. So it has, within the expression, has x0. Suppose when observation starts and clock also starts from the same reference point. Suppose यहीं पे t equals 0 होता, for this diagram x0 becomes 0. जहाँ से ऑब्जर्वेशन मीन्स जहाँ से रेफरेंस पॉइंट मार्क किया, अगर वहाँ से क्लॉक भी स्टार्ट कर दिया गया होता, सो इन दिस केस x0 becomes 0. So finally you will get the distance equals to speed into time. So try to understand difference between these two. Both are same but have the difference of only x0, that x0 is the initial displacement and called the kinematics equation in uniform motion. Now we have the topic to equations of motion. See here the equations of motion. Equations of motion. There are three basic there are three equations of motion which are applicable for an uniform accelerated motion. Listen, equations of motion, you know the three equations of motion. First is v equals to u plus at. Second is s equals to ut plus half at square. And third is v square equals to u square plus 2as. These three equations of motion are applicable for the motion which has a constant acceleration of the body, and this constant acceleration is denoted by a here. So we have to derive these three equations of motion by calculus method here. In class 9th you have learned to derive three equations of motion by graphical method, and also there is one method, conventional method, but here we have practice for deriving these three equations by calculus method, by integration method. Let's see how. Suppose this is point O from where the observations are taken of a moving object with constant acceleration a. When it reaches the point A, time equals to 0, displacement is now I am marking here as 0 because we will use for displacement s, because in 3 equations of motion the symbol is s we are using. So when time is 0, initial displacement is s0. This s0 may be 0. I am marking here. Try to understand. S0 may be 0 when the displacement is 0. It means when the t is 0 at O, means जब वो O पे था तभी वहाँ पे टाइम क्लॉक स्टार्ट किया गया, तो for that case S0 will be 0, but for general expression we have S0 initial displacement when time is t, suppose displacement is S, and also suppose when body reaches the point A, its initial velocity is u and final velocity means at time t velocity v. For this motion body has its constant acceleration a. सभी पॉइंट्स को चेक करो क्या है. This is the straight path of the body moving along the positive direction of x-axis. O is the reference point from where the observations of the body are taken, and when body reaches point A, the displacement, initial displacement s0 when t is 0, and velocity of the body at A is u. After time t means देखो 0 से t हो गया, मतलब time interval is t, the velocity becomes v and displacement s. So for deriving first equation of motion, first equation of motion, you know the formula of calculus form of instantaneous acceleration. It is dv by dt. Yesterday we have discussed about this relation. A equals to dv by dt. This is instantaneous acceleration. So by cross multiplication it is a dt equals to dv, or you can write it as dv equals to a dt. dv equals to a dt. I am repeating again here, this is not the product of d and t. dt is the small displacement denoted by dt. Here also dv is not the product of d and v. It is dv, एक term है that represents the small change in velocity. So after this step you will write integrating suppose equation number 1, integration equation number 1 with respect to yeah, you can write here, integrating equation number 1 with suitable limits means finite integration. Finite integration is also known as definite integration. Some books in some book you will get this is definite integral, yeah, finite integral. So see here we have to integrate this equation. So integration symbol dv, integration symbol a dt. You can write here integrating both sides. You should write here integrating both sides of equation number 1 with suitable limits. So this is the integration symbol applied on both the sides. Now we have to apply the suitable limits. अब suitable limits क्या हैं? So see here, Try to understand. This is velocity term, and in this side time term. So we should apply the limits of velocity in left side and for limits of time on right side. So see here, when time is 0, initial velocity is u. देखो कैसे कर रहे हैं. When time is 0, initial velocity u, and when time is t, velocity becomes v. So I am writing here, when time is 0, then velocity is u, and when time becomes t, velocity becomes v. तो ये हो गई suitable limits for integrating this equation with suitable limits. देखो क्या किया गया. Using the definition of instantaneous acceleration, we have written a dt equals to dv, and or dv equals to a dt. By integrating both sides of this equation with suitable limits, we get this relation. ये जो symbol बना है elongated shape of the s, integration symbol. Limits कैसे मार्क किया देखो. When time is 0, velocity is u. When time t, velocity v. See the diagram here. In yesterday lecture we have discussed some integration formula. There you can mark one more formula for integration. See here, integration of 1 with respect to x is equal to x. Suppose limits are a and b, so for this integral we will apply a to b. See here, integration of 1 with respect to x, this is dx. Integration of 1 with respect to dx with respect to x is equal to x, and with the limits are a and b, then it will apply by limits a and b. And how we will apply the limits for the integral? First we replace the variable. Yesterday we have learned for this कि the variable is replaced by the upper limit first. So b, x पे क्या लिखना है, b minus sign, then again variable is replaced by lower limit, it is a. See here. So also mark this formula, mention this formula in your notebook in the integration part. So we will use this formula. This formula we will apply here. See, this is dv, or you can write here 1 dv u to v is equal to, see here, a is the constant, so you can put it outside, a 0 to t, or you can write here 1 dt, है ना. Anywhere you can put 1 in the product form, because by multiplying 1 the number will get no change. So see here, now we have to integrate 1 with respect to v. So the integral is v, and limits are u to v. A is outside of the integral, we have to integrate again 1 with respect to t. So integral is t, and limits are 0 to t. So how to apply the limits here? Upper limit minus lower limit. V is replaced by v first, so it is v minus v is replaced by u, then u, v minus u हो गया. In this side, a, t is replaced by t first, so it is t, minus t is replaced by 0, means lower limit, so it is 0. Finally, v minus u equals to at, or v is equal to u plus at. This is the first equation of motion. This is the first equation of motion derived by calculus method. देखो डेरिवेशन स्टेप जो है सीखना आसान है, बट एग्जाम टाइम में जनरली जो स्टूडेंट्स हैं भूल जाते हैं इनिशियल स्टेप क्या है, हाउ टू स्टार्ट द डेरिवेशन ऑफ द इक्वेशन. So you should learn by your own techniques or your tricks, or you can learn by this way कि for deriving the first equation of motion we starts by the definition of A, instantaneous acceleration. So try to understand the steps involved in the derivation, and also you have to learn you have to remember the initial step of the derivation, because we have the three equations of motion we have here, and for the derivation of the first equation we should start by definition of instantaneous acceleration. See here, now for the second equation of motion. For the second equation of motion, so for starting derivation of second equation of motion, you should use the definition of instantaneous velocity. Yes, one day before we have seen the instantaneous velocity. It is equals to dx upon dt. Instantaneous velocity is dx upon dt. So start by this step. See here, you can write it as dx equals to v dt. Dx equals to v dt. Or dx is equal to, now you know the value of v. By the first equation of motion, it is u plus at. This is u plus at. By the first equation of motion, v is equal to u plus at. So we are replacing v by this term, and outside this is dt. Suppose mark कर लिया equation number 2. Again here we have to use the integration method. So you will write integrating both sides with suitable limits of the equation number 2 of equation number 2. Again we have to use the integration method, so use a symbol for integration, dx, or here also u plus at dt. Now let's use the suitable limits. See here, this is about the displacement, x is displacement or distance, or this is about the side of time. So we will use the limits up, lower and upper for displacement here, and for time we should use the limits here. So see here, when time is 0, displacement is s0. When time is 0, initial displacement is s0. When time is t, displacement becomes s. So these are the limits. Limits मैंने क्वेश्चन करो. When time is 0, displacement is s0. When time is t, displacement becomes s. तो ये हो गया ready for the integration of this equation. So now let's integrate again. This left side you can put here 1 for integration, and you know the integration of 1 is with respect to x is x. Integration of 1 with respect to x is x. So this is left side x, and limits are s0 s. lower limit, upper limit, S0, S. Now for the right side we have two terms. So integration will apply on both the terms individually. So integration 0 to t of u dt plus integration of integration with limit 0 to t of, this is at dt, at dt. अगर बोर्ड पे क्लियर नहीं शाइन कर रहा है तो ट्राई टू अंडरस्टैंड. आई एम रीडिंग दिस इज इंटीग्रेशन ऑफ 0 to t with at dt. So applying the limits on left side, this is s minus s0 na. How? First x is replaced by s, so it is s, minus x is replaced by s0, this is s0, equals to, here this is dt, u is the constant, so it is outside of the integration 0 to t. Again you can mark here 1 dt plus a is again constant here, a integration of 0 to t dt, और t dt को हम t power 1 into dt कह सकते हैं, t power 1 dt. So left side is s minus s0, u is outside of the integration. Integration of 1 with respect to time is t, so it is t limit 0 to t plus a outside of the integration. Now this is t to the power 1, we have to integrate t to the power 1 या t with respect to t, and we have the formula integration of x to the power n with respect to x is equal to x power n plus 1 upon n plus 1. So using this formula, see this, compare these two. In place of x it is t, and in place of n it is 1. So integrating t to the power 1 with respect to t, we have t to the power, क्या करना है, एक्सपोनेंट को 1 बढ़ा देना है, so 1 plus 1 it is 2, and divided by n plus 1 means it is 2. Limits 0 to t. So for this step we are for this integration of this term we are using the general formula. Finally s minus s0 u, so t is replaced by t first, so t minus t is replaced by 0, so is 0 plus a, you know that 2 is the constant, you can take out from the limit because जो limits हैं वो variable पे apply होती हैं ना कि constant पे. So a by 2, ये 2 बाहर आ गया, so a by 2 and t square पे apply करना है 0 to t, और s minus s0 is equal to, this is t, so ut, I think the board is clear, the contents are clear. Ut plus a by 2, and this is t is replaced by t, so it is t square, minus t is replaced by 0, it is 0 square. Finally s minus s0 is equal to ut plus a by 2, this is a here 0 was there, t square only. So finally s minus s0 equals to ut plus half a t square. This is the second equation of motion. but you have learned in class 9th it is s equals to ut plus half at square. सो भाई ये s0 कहाँ से आ गया, s0 क्यों आ गया? सो दिस इज द इनिशियल डिस्प्लेसमेंट, और स्टार्ट में मैंने बताया कि s0 में बी जीरो, s0 में बी जीरो. कब जीरो हो जाएगा? when we start the observation from reference point. O से ही अगर reference point O से ही अगर observation start कर दिया जाए, जो डायग्राम लास्ट बनाया हुआ था ये देखो, अगर यहीं से ऑब्जर्वेशन स्टार्ट किया जाए मींस t इक्वल 0 यहीं पे मार्क कर दो. फॉर दैट केस s0 बिकम्स 0. फाइनली s माइनस s0 को आप s लिख दिया जाए इक्वल्स टू ut प्लस हाफ at स्क्वायर, और लिख दो यहाँ पे व्हेन इनिशियल डिस्प्लेसमेंट इज 0. जब इनिशियल डिस्प्लेसमेंट 0 होगी then finally you get this form of second equation of motion. And for the derivation of third equation of motion we will see tomorrow, है ना? So practice for the derivation of three equations of motion here, and by practicing this derivation of two equations of motion we have practiced here, we have completed here. You will get the concept of integration method, how to apply the integration for the function and how to apply the limits. So this will help you to understand the integration method. Integration, that is the mathematical tool. So for today's lecture, thank you very much and God bless you. Keep learning.